Hi, Steve Feldauer here for Abbott Furnace Company. We use the term dew point so often when we're trying to control a process. But what does that really mean? So let's talk about that a little bit. The term actually comes from the weather. When we hear the weatherman talk about the dew point, we know that if the temperature drops below the dew point, we're going to get dew on the grass. But how does that work? Well, I have a little model here. And if we imagine that these green dots were air molecules, see, as the sun comes out and heats up, it puts energy into those molecules and they start to vibrate, they start to move around, okay? And you notice how there's now space in here. Well, that sun starts to evaporate water from the creeks and from ponds and things. And if I use, so let's say this ping pong ball represents a water molecule, and it vaporizes and it comes up into the air, and now there's space in here that water molecule can be held in the air. And as the water continues to evaporate and the air keeps getting hotter and warmer and more excited, we can keep adding these water molecules and it can hold it, okay? And we can keep adding more and more, okay? And you can see how inside here now it's holding, there's space. It's holding those water molecules, and we can keep putting more in and it starts, you can feel it. When you breathe in the air, you can feel the moisture. But then as the temperature goes down, as the sun sets and the energy starts to leave the air and it doesn't vibrate as much and things become more dense, notice how it collapses around the water molecules, and now those water molecules fill this space. And if I get any colder, at all, the only way that this air can actually can shrink or condense and become more dense is to kick one of these water molecules out. That temperature where the water molecule has to come out because there's not enough room to hold it all in the air because the temperature has gone down, now the energy has left the air, and now there's the air is more dense and there's not enough free space. That temperature where it kicks it out, that's the dew point. So how do we use that in processing? Well, in our case, we start off with atmosphere in our furnaces or in our processes that's very dry. So maybe we have just a little bit of moisture in there. But it's really critical for us to know how much moisture is in there because that's going to affect how we clean, okay, the H2H2O balance in our furnace. And so whether we're reducing or we're oxidizing. So what we do is we bring that atmosphere out of our process, and what we do is it's coming out and it's warm, and we cool it down. And we cool it down until it gets so small it kicks out one of the water molecules. And at that temperature where it kicks out that water molecule, that's the dew point. But we also know that at that temperature, we know the density inside that atmosphere. So now we know the volume, the free volume that was in that atmosphere. So now we know exactly how much water is in our atmosphere. So we use the dew point as a mechanism to measure the amount of moisture that's in our atmosphere. And that allows us to control our processes. So that's dew point. So, and as always, if you have any questions, please feel free to give us a call here at Abbott Furnace, and you have yourself an awesome day. Thanks.